Hello, this is Vairav. I am making a series on the basics of astronomy. Astronomy is a special science. Astronomy is the physics of big things. I like astronomy because of how it portrays us, humans. In physics, we are made out of quintillions of particles. In chemistry, we are made out of quadrillions of proteins and other molecules. In biology, we are made out of dozens of trillions of cells. In astronomy, we are tiny beings upon a tiny planet orbiting an insignificant star in a random galaxy, which is a tiny piece of the observable universe. And I am saying observable universe because we do not know how big the universe is. The light from the other parts of the universe have not yet had time to reach us in this 13.8 billion years. Obviously, we can't talk about everything. This series will cover stellar evolution, stellar remnants, and the ultimate fate of the universe. Let's start with gravity, as a refresher will be required because everything in this course is mostly about gravity. So let's jump right into it. Gravity is one of the four fundamental forces of nature, the other three being the electromagnetic, strong and weak nuclear forces. Unlike the other fundamental forces, gravity is not communicated by subatomic particles. It is instead the effect of the curvature of space-time on matter. When there is matter, space-time curves around matter, as you can see in this image. Due to this curvature, objects are attracted to the planet. The more mass an object has, the more of this curvature it causes upon space-time. This is how gravity works. If an object is going fast enough, it can avoid crashing into the other object, and the two can orbit each other. For most objects, however, it is more of one thing orbiting the other, as usually the things orbiting each other, one is much more massive than the other. Which is why in the Earth-Moon system, the Earth and the Moon actually both orbit around a point inside the Earth. So, what happens if an object goes much faster than the velocity required for it to orbit the other object? Then they can fly away from each other forever. The minimum velocity for this to happen is called the escape velocity. In this animation, you can see this is almost the escape velocity, as the ball almost flies away, but then reverses course at the last minute and comes down. It will become very important later. The escape velocity of any massive object is very high. The Earth's escape velocity is 11,200 meters per second. For a comparison, the speed of sound in air is 343 meters per second, and the orbital velocity of the Earth is 8,000 meters per second. Summary. In this video, we learnt that matter bends space-time, and bent space-time tells matter where to move. We also learnt that objects can orbit each other if they are moving fast enough. We also learned about escape velocity, which is when two orbits move away from each other indefinitely. The next video will be about stellar classification. See you then!